Today, I want to talk about the second derivative test and what it lets us find. So here we have a pretty simple function, x to the fourth minus 2x squared, right? And let's take the first derivative. So we'll get f prime of x equals 4x cubed minus 4x, right? That's our first derivative. So in the past, we've set that equal to 0, and we've set up the little borders, right? Or not the borders, but the little intervals, right? And we figured out the local minima and maxima. Now what we're going to do is we're going to take the derivative of this, right? We take the derivative of the derivative, so we get f double prime of x, and that will equal 12x squared minus 4. Then, from here, we're going to set it equal to 0, just like we did for the first derivative test, and we're going to solve, right? So obviously we can just start by factoring out 4, and we'll get 3x squared minus 1 equals 0, right? Then we get 3x squared equals 1, right? X squared equals 1 over 3. We get x equals the positive or negative 1 over root 3, which equals positive or negative square root of 3 over 3. Okay? Then from here, we're going to set up those little intervals like we did for the first derivative test, right? So we create this and say, so we're going to put negative square root of 3 over 3 here. We're going to put square root of 3 over 3 there, right? And go up, right? And now we have our little intervals. So now what we want to do is let's take a value 0, a value in between these two, right? And let's determine, is the second derivative negative or positive, right? Well, this inside here, that will be negative, right? And this will be positive. So a negative times a positive is a negative. Then, let's say we take a value, so now we'll take a value greater than the square root of 3 over 3. Let's say we take 10, right? Obviously, this will be positive, and this will be positive, right? So we'll get a positive value. Then, let's say we take, once again, a number less than the negative square root of 3 over 3, right? And once again, this will be positive, and that'll be positive. So we have this. So before, what this helped us do was determine local minima and maxima. Now what we are doing is determining concavity of the function, right? So when this interval is positive, we can say the function is concave up on that interval. When it's negative, we can say the function is concave down on that interval, right? And what those mean for us is, let's recall what concavity means, right? Let's draw, so something concave up will be like a positive parabola, and something concave down will be like a negative parabola, right? So what this interval can help us determine is when we should be drawing something like this versus when we should be drawing it like this, right? That's what we're determining when we take the second derivative test, and that can help us graph the function, right? It can give us more insight into what it will look like. Thank you for watching my video. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.